Hello, sir. Now I will discuss methylammonium oxide CH3 and PBI. This is commonly used material in the perovskite solar cell. It is good light absorber in the whole visible solar emission spectrum. It has weak binding energy of exciton produced by light absorption, and it is approximately 0.03 electron volt. The time of recombination of electron and holes is 100 of nanosecond. One of the property of the perovskite material is that the band gap energy is not only depend on one type of particle but on the whole cell, and that property of the perovskite material helps to tune the band gap of the perovskite. Now, band gap tuning is required to extend the absorption to the longer wavelength without sacrificing the absorption coefficient. Changing in any of AM or X in AM X-ray changes the band gap. The band gap also can be tuned in between 1.55 electron volt to 1.17 electron volt by changing the ratio of lead is to 10. Here MAPB 1 minus X SNX I3. The band X is equals to 0.25. 0.25. The band gap is 1.24 and X is equals to 0.5. The band gap is 1.17. But here we can see for X is equals to 0.5 and X is equals to 0.75. The band gap energy is same, but the conduction band energy and valence band energy is different. So sometimes to tune the valence band and conduction band energy with the HTL or ETL, we have to tune the materials by changing the ratios. Now I will discuss the perovskite solar cell structure. The efficiency of the solar cell does only not depend on the perovskite band gap energy, but also depends on the device structure, related material, and the intrafacial modification. There are two type of structures. One is mesoscopic nanostructure, and other type is planar structure. Uh, Here we have two layers. One is electron transporting layer, which is used to collect and transport electrons, and one is hole transporting layer, which is used to collect and transport holes. Now, now I will discuss different type of solar cell structure. One is mesoscopic NIP structure. Uh, Here we have from the bottom we have transparent electrode, and then we have the ETL, which is CTiO2, then MTiO2, which is mesoporous TiO2. That is called that is called we have called him mesoporous NIP structure. Then we have the HTL, then we have the metal electrode, and the second type of mesoscopic nanostructure is HTM free structure. Here we have transparent electrode, then CTiO2, then MTiO2, then M zirconium oxide, then carbon layer. Then on the top of it, we drop perovskite materials, and then we have the planar NIP structure. We have First we have transparent electrode, then we have ETL, then we have the perovskite material, then we have HTL, then the metal electrode. In the case on inverted, the metal ETL and HTL are reversed. Means first we have transparent electrode, then we have HTL, then the perovskite material, then ETL, then the metal electrode. Okay. Now I will discuss the electron transport. The basic function of electron transport layer is to form the electrons selective contact with the perovskite light absorbing layer. The second is improve the extraction efficiency of the photo generated electrons, prevent the hole migration to the counter electrode, reduce the recombination of holes and electrodes. Properties required in selection of the material for ETL, like how to choose the material which is preferred for ETL. First is high electron mobility, transparent invisible light. This is because we have to supply the sunlight to the material or the sun. Then the band gap should match with the perovskite layer. Then preparation of the material at stable condition and temperature. The working of whole transporting layer. Whole transporting layer is used to collect and transport holes from the perovskite layer to promote the separation of the electron hole pair in perovskite material through cooperating with the electron transporting layer. Properties required for the selection of the material are HTL. That's a mistake. HTL means properties. I have to choose the material which fulfill the property of whole transporting layer. The properties are high hole mobility, wide gap, simple solvent process, then film so and the electron transporting layer we used the TIO. Here we see the here first the sunlight hits the HCl material, then ETL TU, and we take the output separate voltage uh, as from FTU, and I the right side is the contrast layer and the that is so that first we the top we FTL hitting the sunlight to the perovskite, and from the right side hitting sunlight electron transfer. This is uh, my part is finished. Arpit, you can stop the recording.